Hi guys and welcome to this session by Intellipaat. So PyTest is a testing framework in Python which is used to test pretty much anything from APIs to databases. You can write code to test all of these things. And today we'll be having a session on that to understand what is PyTest all about. But before we get into all of that, please subscribe to our channel to never miss an update from Intellipaat. Now let's talk about today's agenda. We'll start today's session with a brief introduction to unit testing and we'll talk about why unit testing is necessary. From there, we'll talk about the various different testing frameworks in Python. And after that, we'll have an introduction to PyTest, and from there, we'll move on and assess functions in Python. And finally, we'll have a full complete code walkthrough. Also guys, we do provide end-to-end training for Python. So if you're interested, you can check out the course details given in the description below. Now, let's just get into the session.
Well, firstly, I want to ask if you guys actually knew this. Whenever we talk about testing, software testing, unit testing, whatever forms of testing there is in the world of IT, there is a reason that testing has been so rigorously enforced in many softwares in most of the companies across the world. Because this boils down to three very simple points as shown on your screen. The first thing is that whenever you test your code or whenever you implement code which is easier to test and easier to work with, it means that this will immensely increase the quality of the code where you can work with multiple collaborators easily and not have to worry about anything affecting the quality of the code as well. The second point is readability. So whenever you perform testing or whenever you have testing friendly code, it makes it very nice. It makes it very highly readable because with testing comes a lot of documentation. With documentation, again circling back to the same thing. So it's this life cycle of code. First the code is written, then it gets tested, then it gets documented, and then back from the documentation you can implement more features into the main code, write the code again, test it again. So it's this one very nice circle in the world of testing. Now, if you have to talk about cost reduction, in my opinion, testing is used mainly to reduce the costs. Because let's say you implement something right now, let's say you implemented a new feature using your program and you wanted to test it and it wasn't possible. So what you did is you wrote a testable piece of code. So after writing a piece of code which can be tested easily, you implemented multiple new features only to realize that you could have done it in an easier way on the first try itself. So you just put in more time, you just put in more effort to do something which might not work or to do something which is redundant. So this again is a very important thing about testing. Now, when you're talking about testing as a career path, you need to understand that this is one among the top career paths for this particular decade. So you might be wondering about automation testing, implementation of artificial intelligence with respect to testing, and that it's been taking up all of the jobs of the people across the globe. Well, to implement automation testing, robotic process automation, all of these concepts, you still require a lot of manpower. And since the concepts gets more fancier and fancier to help the world of testing, this creates a whole lot of jobs. So in case if you guys are in the market and you're looking for a testing job, well, it's an amazing time to be a person who's enthusiastic about testing and wants to build a career in it. Now, coming to the introduction to unit testing, well, what is unit testing? Unit testing, in my opinion, is basically a very simple procedure to perform software testing where, as the name suggests, unit testing is to pick up every single unit, is to pick up tiny single pieces of your code and to test it individually. And why is this done? Well, if you have lines, when you have program where, you have 100 lines of code and you're doing 3 or 4 different things, you can split that entire program and then test each of these individual components that you have. You can check for function calls, what the functions are doing, if the values are right, and all of that individually. But then you can do it together as well. Well, it's not called unit testing if you're going to do it together, because if you do not break it down into the most simple entities into the programs where you're checking it separately to make sure, it's like you're working your way up from one single brick. See, when you want to build a wall or when you want to build a house, you keep each individual brick and then you work with it, right? So think of unit testing as the same analogy. So you're going to start with one brick and you're going to keep going on building on top of that. Now, coming to why one should perform unit testing, well, unit testing is mainly performed to find bugs and remove bugs. And once you go on to do a good amount of debugging to fix your code or to find anything hidden, where it's not supposed to be doing the wrong thing, where let's say there is a feature which is misbehaving, which you could not find out when you're working with the application. So you can hunt for these features, hunt for instability, and then fix it up as well. And of course, when you're talking about feature implementation, you can use the product of a previous test case to build new features into your existing models too. And of course, unit testing forms to be a very vital methodology which eventually leads to a program which has been documented very nicely, because when you're working with programs, when you're working with code in a production environment, there is a good chance you're going to be working alongside a team. So when you're working alongside a team, what basically is required is very good amount of communication. So high amount of communication with respect to your code only can come from good documentation as well.
Just a quick info guys, we do provide end-to-end training on Python. So if you're interested, you can check out the course details given in the description below. Now let's get back into the session.
And as I mentioned at the start of the session, unit testing is done to make sure that costs are kept low. Let it be any company, any product, any software service, or whatever it is. The main goal, if they are providing something to you, is to make sure that the quality is at its highest with respect to cost being at the lowest. So that balance of keeping the quality high and bringing the cost low is very important, and in fact unit testing helps a lot here. So what do you guys think about unit testing? At this point of time, head to the comment section and do let us know. And then coming to all of the testing frameworks available in Python, there are three main testing frameworks which are very much used in today's world. The first thing is unit test. Unit test actually comes as a standard Python package where you install Python, unit test comes installed with it. Then there are two other packages called Nose and PyTest. Nose and PyTest are two of the most used testing frameworks whenever someone's working with Python. PyTest especially. Nose was popular and it has its own niche applications, but then for a majority of conditions, for a majority of test cases or usage policies, PyTest is amazing, and it is very simple to work with, as you'll start learning with code in just a few moments of time. And then whenever we're talking about PyTest, the first thing, the only thing that comes into my mind, let me rephrase, not just PyTest. When you're learning any library, any framework in any programming language, right, the first thing you need to do is get your hands messy with it and start working with it. Because if you tend to read a lot of documentation, if you want to read a lot of theory before beginning, one of two things might happen. You'll either get bored or it'll be very overwhelming. So to avoid all of this, make sure that you actually get your hands dirty with code and you can begin working. Alright, so the first step to working with PyTest is to installing it, guys. So pip is basically a package manager. Pip install PyTest will basically install PyTest for you guys. Now on that note, we need to check out a keyword called as the assert keyword in Python. So basically, when you're talking about literal terms, not in programming terms, whenever you say assertion means that you're confident about something. So assertion is basically a statement where you're telling someone something and you're very confident about it. Now in programming terms, let's say division by zero. So in programming terms, you should know, even in real life, you cannot divide something by zero. So the divisor cannot be zero, right? If it's zero, then you will have to hit an exception condition. Now, whenever we're talking about using the keyword assert in Python, assert is basically trying to check if there is something being done which is not supposed to be done. So whenever you're using Python, the assert keyword is basically used to confidently represent that something should be done or something cannot be done. So with this, let us actually jump directly into code, and from now until the end of the tutorial, we're going to stay in code. Let's go hand in hand. If you want to write code right next to me, make sure to open up Google Collab and we can work with it together as well. Now coming to Google Collab is basically a Python Jupyter notebook which is hosted on the Google Drive. So it's like a Python IDE, but it's on the Google ecosystem, right? So you can write code directly instead of having to install Python on your native machine and do all of that steps which is required to install Python. In my opinion, this is the most simple way to go about it. But then of course, you can have a Jupyter notebook and you can do multiple things as well. So the first thing whenever you open up Google Collab or anything is to connect, because if you do not connect to their processing system, you really cannot execute the code. So first thing is you need to connect to the runtime to make sure you can actually use it. Of course, whenever you run your first piece of code, it's going to automatically do it for you. But then as you can see on the right, it's going to say connected. Now you can begin typing any Python code. The first thing I always do is I always name my Jupyter notebooks. So let's name this as PyTest tutorial. Perfect. So what's the first thing whenever we work with PyTest, right? So whenever we work with PyTest, as I told you, the first thing is we have to install it. So let's install PyTest. I just have to hit the play button to run that particular cell and execute that piece of code. Since we are running this on Google Collab, it would have already downloaded it and everything is available in the backend. You can already see a message which says requirement already satisfied. It means that you do not have to install PyTest again and that PyTest is already there. Perfect. The first step is done. Well, the second step, let's check out how the assert function works, right? So what's the easiest way to check out how assert function works? So let me quickly declare a string x equal to hello, and then pretty much we can have an assert function, in fact, directly on this to check if our message has been something that we have already typed or not. So the first parameter you're going to give to your assert function is the actual message to check the condition, and the second one is what you want to print if there is an error. So if the assert is not hello, well, you're going to print something called as, let's say, x should be hello. Perfect. Now as soon as I run this, it's x is not equal to goodbye, right? So here we have x equal to hello, and here I'm telling that check if x is goodbye. X is not equal to goodbye, so it's going to throw an assertion error. This is how you basically perform testing to see if something is wrong. With respect to assertion error, it's printing the message that we actually just put up in the second part of this, right? So we have told it to tell us if it's not hello, then this print this. So in our case, it's printing that x should be hello and x should not be goodbye. If x was hello here, of course you wouldn't get the assertion error. Your test case would pass and eventually it would work with it. So strings are done. So this is a basic string example. Now what we can do is we can actually check out a math function. So let me create a file in Google Colab. So creation of file is basically very simple. All I have to do is % file and give that file a name. So if I am doing, I'll call it math underscore functions and .py, of course. So under this, my bad. So I just hit shift enter. Shift enter is to basically run it. Right. So under this is where you'll actually write all the stuff that needs to go into this particular file. So let's import the math function quickly, and then we can define a function called as, call it test underscore add. We'll perform an addition operation. So basically here we can assert if 1 plus 1 is equal to 2. Of course we know that 1 plus 1 is equal to 2, and we have kept it very simple here, but then in multiple cases you might run into thousands of numbers where you have to check it individually, right? Okay, so let's do another thing. Let's do multiplication. Perfect. So test underscore mul is a function. Let's assert to see if 5 into 5 is equal to 25. Well, now it has to run true for all the cases as soon as I test it. But then first let me write the file. See, now as I told you, what Google Colab does is it basically writes this into a file. So if I go into the files bar on the left here, you can see a math underscore funcs.py file created. You can right click on it, download it, delete it, rename it, do whatever you want. So how easy is this, right? So basically we have created a math underscore funcs.py file and we have put in all of these details into that. Now if we have to actually perform PyTest, let's run our first PyTest code, right? So I just have to type in Python m, where we're going to print messages about it. PyTest, this is the actual syntax to actually run PyTest. And what is our file name? It's math underscore funcs.py, and I can give in another attribute called as v. V is basically telling it to show us if the test case passed or failed. Without it, it will still run fine. See, now we have two functions, test underscore add and test underscore multiplication. Both of them passed. Why did both of them pass? Because 1 plus 1, yes, it is equal to 2, and then 5 into 5, yes, it is equal to 25. Now whenever you're working with testing, negative test cases will hold a lot more power than the positive ones, because positive ones, yes, they just passed. Negative ones, as soon as they start failing, then you start fixing something, right? So see, 5 into 5 is 25. We already know that. So let me make it as 20. now the program will understand that 5 multiplied with 5 is not 20, it is 25. Now it's going to say that particular test case failed. So I have to save it again by clicking on the file path, and after which I can run the next piece of code, which is the PyTest code. And here you can see in green color you have assert 5 into 5 is equal to 20, and it says, hey, this is wrong. This particular function, there is an assertion error here where our add still passed because 1 plus 1 is still 2, but then when we're talking about multiplication, it failed because 5 into 5 is 25 and not 20. How simple is this, right? So whenever you're working with PyTest, your entire piece of output will be more of errors. So whenever you go on to see these errors, do not be overwhelmed because you are hunting for those errors. You're looking for those errors on purpose. So that's one more thing that I just wanted to tell you guys.
Just a quick info guys, we do provide end-to-end training on Python. So if you are interested, you can check out the course details given in the description below. Now let's get back into the session.
So the next thing we can try to do is we can do something called as entity comparison. So let me quickly type this into the header. So this is just for readability. You don't have to do this, but then this is going to help to keep a track of the file later. So when we're talking about entity comparison, we are trying to match something to something else. So what I basically mean is that, let's say we want to print a couple of letters on the screen and we want to see if we have entered those letters or not. In that particular case, what we're trying to compare is we're trying to tell the function to see if it can find any differences between what has been entered and what it finds. So let me go and write the code and you'll find it simpler. So percentage file to create the file again. I'm going to call it make underscore triangle .py. .py is important because that's where you're telling it to give the file extension compulsory as well. Then we're going to define a function. I'm going to call the function again make triangle, of course. You can have it in any name that you want, but then I'm just using it. We're going to pass one parameter to it because we need to find the ranges later. Perfect. And then let's go on to put in a multi-line string. So we will be drawing a triangle using let's say at letters, right? So at letters. Perfect. So what are we actually trying to do? So let me give you an example here itself. So for instance, let's say you're trying to do this particular thing, right? So we're gonna print a slash and a new line character, of course, and I'm gonna eventually have that joined to a statement where we're passing it through make triangle 3 times. So this is perfect. Okay, so this is one redundant bracket. Wait a second. Yep, that's perfect, right? So as soon as you run this, what you'll basically have to see is something like this, right? So so we're trying to print a sequence of ats out here. That's it. So basically we need to test this. This is the actual code which will be running in the background in the actual file that exists. Now to go on to achieve this, basically let us create a for loop for I in put a range. Range is n because we're trying to pass that to our function out here. Let us use the yield function. Yield function is very nice to work with. It's pretty simple to work with, and I'm sure most of you guys have worked with the yield function as well. So as soon as I go on to save this piece of code, all we're trying to do is create the file which we have to test. Now if you're creating a file which we have to test, we have to basically write the test file as well, right? So there is a certain criteria whenever you go on to write the test file as well. So if the actual file is called as make triangle, our test file is going to be called as test underscore make underscore triangle. So basically that's one very nice sort of standard structure that you can use to keep a track of all of your testing files and the actual files that you have to test as well. So I'm going to call this, as I just said, test underscore make underscore triangle, of course, .py. And so from our particular file we need to pick it up. So from make triangle, we're gonna import make triangle. Perfect. So again I did the shift enter thing. I'm so used to directly entering it. So perfect. Coming back, we're gonna define the function test underscore make underscore triangle. Let's check out what the actual outputs are, what's the expected output, and all of that. So when you're defining the function, let's call it expected output. So the expected output is supposed to be our @symbol. What is the actual output that you might see? You're gonna see a /n, right? Because every time it has to move to a new line character and all of that. The same thing, join make underscore. You can just copy it from the above thing as well. So I'm just entering it manually again. So as soon as this is done, we have to now assert it. The expected value is given, the actual value which will arrive there is given to make sure that we can find an error there. Now to check if we have an error, we'll assert actual value to the expected value. Right, now I'm gonna save this particular file into our test underscore make underscore triangle file. And now, as you might have already guessed, we need to run this particular thing with respect to PyTest, where the file that you have to test is the one that you have to send to PyTest. So we wrote make triangle.python file and test underscore make triangle.python file. So PyTest has to see this one, because this is where, again, you're basically importing make triangle into the test underscore make triangle and using it as well. So instead of a double import, you can just literally import test underscore make underscore triangle, and it will still work as well. So as soon as I go on to run this piece of code, it is going to give me an error right now, because at the end of the day, what it's telling me is that, a blank space or a character, it is not equal to the @ symbol, right? So this assertion error just told us that it basically failed because we're not matching two things. And of course, if both of these were @, then it would just match and the function would run and it would work fine, and you would see a passed test case. So again, to iterate what the v flag does or the v attribute does, just keep your eyes on this particular piece. It just says F right now, right? So F, it's saying it's failed, but then just to make it more readable, you can give that flag v, and it's going to say failed and all the red fancy colors out there. All right, so now we have arrived at this condition where we have failed the test case, and we understand that there is some error in this particular program that's making it to cause this particular error, right? So we have to fix that. Well, instead of writing the code again, I'm just gonna copy this entire thing. Let me paste it again. So let's have the same file name, make underscore triangle.py. Basically, we're trying to overwrite it. We can have the second version of it, so we will call it as version 2.0 or whatever you want. So make underscore triangle, and all of this will remain same, but then instead of yielding this in a range of n, what we're trying to do is we wanted to print the first one instead of a new line first and then print the @ right? So that's what we were doing until now. What we want now is to make sure we get new line new line So we want this exactly, and we don't want a new line before that, right? So basically, instead of giving the range, and I'm going to explicitly say start from 1 and all the way till n plus 1. So as soon as I go on to run this particular file, again, it's going to overwrite my existing file. Let me copy the piece of code for the PyTest thing. Just click on plus code to add another block. So as soon as I run test make triangle file again, it's going to pass now, because right now it is expecting an @ value. It is going to get an @ value. Before, it was expecting an @, but then the actual value it found out was a new line character. So it says your new line was not equal to @. And now it's basically telling us, yes, whatever value you have put in is @, whatever I'm saying is @, your test case has passed. So again, we will just tell you it's passed in nice green colors, which will look nice whenever you're testing any piece of code as well. So it's as simple as this whenever you're working with PyTest. So another section of this thing we can check out is something called as context sensitive comparison. In context sensitive comparison, basically what we're trying to do is we're trying to compare two entities, let's say two lists or arrays or whatever, to see if it might have the same data in it, if it has different data in it. So if you're comparing like two lists or dictionaries or any of these structured data types which will contain thousands and thousands of individual entities, and you want to see if they're equal or what, or if they're not equal or whatever it is, you can have the easiest way to do it using PyTest as well. So let me create another brand new file. Let me call it test underscore compare underscore fruits.py. So let's compare some fruit names here. Let me define a function test underscore set underscore comparison function set. Let me have a first set here. First set, we're going to use sets in Python for this as well. So open up the big braces for sets. The first entities, let's have apples. The second entities, let's have bananas. It's basically simple fruit names, guys. Next we'll put in like 3 or 4. Let's put in 3 or 4. We're gonna have watermelon, and then of course we're gonna have pear. All right, perfect. Let's just have another set here. Let me just copy this. We'll have another one. This is just to make sure that I don't rewrite it again. So set 2 is set, but let us change some things, right? So we don't want bananas in set 2. Let's have grapes. We don't want pear in set 2. Let's just make it melons or something, right? Now just doing this will if I have to execute this right now, even if it's not just saving it into a file, it'll basically create 2 sets. What is the most important comment or the most important piece of code that we need to write now, right? So take a second to guess. The first thing we'll have to do is to make sure we are performing assertion, correct? Okay, that didn't take it as a perfect. So it's a comment. So we have to perform an assertion, right? So to do that, we're gonna have to use the assert keyword. As I've mentioned, assert keyword. What are we trying to assert here, guys? Set 1 is equal to set 2. Perfect. As soon as I run this, the file is created. So all I have to do right now is to run this, right? So to run it in PyTest, what do I have to do? PyTest where test compare fruits is the name of the file. Compare underscore fruits.py. You can have the v, not have the v. It's gonna work either way. So let me click run, and as soon as it runs, it's gonna tell you it's failed. Of course it will fail. Why is it failed? Apples is equal to apples. Yes, perfect. Banana is equal to grapes. Nope, it's not equal to grapes. Watermelon is watermelon. Perfect. Pear is present in set 1, but pear is not present in set 2. Melon is present in set 2. It's not present in set 1. Again, the same thing for bananas. Bananas is in 1, but it's not in 2. So grapes is an extra in 2, which is not present in 1. So this way, whenever you go on to use PyTest, right, it'll give you, probably you'll be happy only when you see errors whenever you're working with PyTest, because then you've found some kind of faults to, of course, print an even more detailed output. Instead of using just the v flag, make sure to use a vv flag. That's double v, and it's going to give you an entire output without truncating it at any point of time as well, right? So now coming to the working of fixtures. So let me quickly type in the code, and we can work with it from there. So guys, I just took a couple of minutes and I wrote down the entire code which is required for the fixtures part as well. So whenever you're talking about fixtures in PyTest, it is a concept which will help you avoid any sort of redundancies. So when you're talking about a fixture, the concept is very simple. Instead of writing a piece of code that you want tested, an attribute or anything multiple times, you'll basically call a fixture in that point of time where you want to test that entity, right? So to understand this better, now take a look at the example. Here is a rudimentary regular way of performing of actually defining a class and working with it. So I have a class, I've called it person. The person has a name, a favorite color, and the year that they were born, right? So basically I'm trying to self instantiate the class, name equal to name, favorite color equal to year born, and all of this. Now let's add a couple of friends to this particular person. So friends will have one instance, it's called as the other person instance, and if this person is not a friend of our person, let's say our person is A. Now if this person is not if this friend that we are calling is not a friend of our particular A, we're going to raise an exception. All right, so as soon as I'm going to run this example, you will understand this piece of code better. Now Now let me quickly come to this part where we're actually writing the test file. So in the test file, what we're trying to do is we're trying to build our entire setup with our friend, and we're adding a friend to that person. So let's call our person as Terry Gilliam. So Terry Gilliam, his favorite color is red, and he was born in 1940, right? So his name is Terry Gilliam. Now we're gonna add a friend to this particular guy, and let's just call this person as Eric Idle. His favorite color is blue. He was born in 1943. All right. So the actual thing that you need to understand in this is, of course, you can break this example into just names, just birth years, just favorite colors, or whatever it is. So we are trying to assert if Eric is Terry's friend and if Terry is Eric's friend. So our person is Terry and Eric is the friend of Terry. It's pretty simple, right? So let me go on to run this. Running this will basically save it. Now to perform PyTest on it. As soon as I go on to run this piece of code, both will test because Eric is a friend of Terry, and then of course in real life it makes sense, Terry is basically present in Eric's friend list as well, right? So this is one simple way that you can work with PyTest, and this is a lot of code which which will already exist. So as a tester, you will not have to write a rudimentary code, a rudimentary piece of testing where you have to write all of this yourself. You'll have to write the test file to see what you're asserting, and you just have to execute it. Now the problem with this is that this is a regular way to do it, so we are not using fixtures here, as you can see. Now to make use of fixtures to work with it, as I told you, fixtures are very nice, very easy to work with, and make using this particular piece of code fun as well, right? Now let me just go on to type it out again. Unless you want to see me type for another 5 minutes, I'm just going to copy this and paste it. So let's pause the video, and I'm going to type out the code, and we can come back to it in a second. Right, guys. So now what we're actually trying to do is we're trying to make use of fixtures here. The above example we just discussed is basically doing the same thing with it has become rudimentary, right? So you have to check out if you have 100 friends or 1,000 friends of this particular Terry person or any person, you have to write an individual case for everyone else. To avoid all of that, we use this concept called as fixtures, and using fixtures is pretty simple as well. So what we're trying to do is we have created another file. This one's a test file. We're going to call it test_person_fixtures1. Of course, you can call it anything you want. We're going to import our particular class function, and we're going to import, and we're going to do all the same things. We're going to define the person names. The person names is going to be Terry. The birth year is 1940. The favorite color is red. Now, so what we're trying to do particularly here is that whenever we call at PyTest.fixture at that particular point of time, it already understands that match this with everything else that there is. And this part of it we have defined in the code here. So we have put in define test_person_name. We are passing 3 arguments to it: person name, favorite color, and birth year. So just try to match this person, friends, or whoever it is in one particular line, instead of writing like all of these particular individual friend entities, and just make sure that you map it and find out if it's true or not. Now let me go on to execute this. The file will be created. Oh well, so this became a word text. So let me delete that. Let me put it back into code. And as soon as I run this again, what I'm basically trying to do is send this file to PyTest, and I'm running it. Now it's going to pass again, but then look at the amount of code that we have to say, put out dynamically, and we have to save, and it's so beautiful, right? So here you might look at it and you might be like, okay, it just looks the same amount, right? There's no difference in the quantity, because I have given you a simple example. There are 2 friends here for one particular guy. Now think about 1,000 people each having 1,000 friends. Now, then this program alone is going to go to like 1,500, 3,000 lines. But then that exact same program is still going to be like 20-25 lines, and it will still work perfectly when we go on to use this amount of dynamism in the particular code. So it works like magic in my opinion, and it's really nice to use as well. Right, so circling back, let's just quickly take a summary of this. We installed PyTest, we checked out how assertion function works, we took out a math function example to work with it, and then we did entity comparisons where we're trying to see and match 2 things that our output and the input sees, and then of course we fix that to make sure we fix our error. So we purposely put in an error there, we fix that error, the code ran fine. Then after which we moved on to context sensitive comparison. In context sensitive, we just checked out entities like dictionaries, sets, lists, all of those comparison of elements, and then we found discrepancies in there. If you want to fix these discrepancies, all you have to do is you have to make this same to see if it's equal to that as well. You can also do assert set1 not equal to set2, where you're trying to check if it's particularly not equal. Then of course the test case is going to pass. Then we checked out fixtures. We checked it out in a static way of programming, where we have to implement each and every name every single time. So we fixed that using fixtures in a very simple way, and then we performed that, and of course both the cases it passed. But then the second time we did it in a very easy fashion. Right now, fixtures has another concept. It's called as parameterized fixtures, and whenever we go on to perform it, let's just call it parameterizing the functions, because we're going to add parameters and directly pass it whenever we're going to use fixtures as well. So that's one beautiful thing that you can do, is you can directly, whatever values you have to compare, you have to assert, and you have to find out in your program, just directly send it into the fixtures part as well. So this way you're saving more time while testing the piece of code. So you might be wondering, is it really going to take all that amount of time? Well, yes, these are very simple test cases. In complex cases, it is going to take a lot of time. So what I'm talking about parameterized fixtures is this particularly. Well, let me create a file and we can begin working with it as well. So file test underscore, let's test for prime numbers, right? So test primes underscore py, and let's import PyTest first. You can understand why we are doing this. Import PyTest, import the math function. Let us define a function is prime. Very simple. Let's pass the argument is prime. Perfect. Is prime. So what are we returning as a part of this function? We're trying to return everything which is like factors, to see if these factors have a remainder of 0, right? So simple code x mod factor to see if it's not equal to 0 or if it's equal to 0. So what are we going to do? We have to run it through all the elements, right? So this is going to just give us for one element. So let's just put in a for loop here for factor in the range of 2. And of course we can have the explicit integer display there as well. So x by 2. Yes, the brackets are all closed. Perfect. So this function is going to check if it is prime. Now comes the magic part. Now comes the part where we're trying to implement PyTest. So instead of just doing a PyTest dot fixture as we previously saw, here are the parameters I'm going to send now. I told you can send in parameters, right? So this is the perfect and simple way that you can go on to do this. So let's send in a couple of prime numbers, 2, 3, 5, 7, 11, 13, 17, 19 and 101. All of these are prime numbers, right? So next let us define for this fixture we need to define the function, right? So define prime number, and where we getting the values from, we have requested it. So let's go on to use request, and of course as soon as this is done we need to return a request dot parameters, because what we're trying to find here to send to our function is the actual parameters value. So we need to send 2, 3, 5, 7 etc to that particular prime function and then work with it, right? So we're going to return request dot param. Perfect. Now so at this point of time we are still not done, because we haven't asserted anything. So we have to define a function where we're testing it for prime. We're doing both the test thing and the actual thing in the same function, hence we had to import PyTest. I'm sure you guys would have got that by now. So what are we passing this? We're passing the prime number to it. What are we trying to assert here? We're trying to assert if it is prime, right? So we need to pass the is prime function. What are the values we need to pass it to this? We need to pass prime numbers here, right? So because we've used the request function to make sure we can pull these values in directly and dynamically, right? So basically the parameters here will be just prime numbers. Perfect. So we are asserting if the prime number here is true or not. So if the condition is actually, if it's actually prime or not is what we're trying to do. So let me quickly go on to save this. Let me open up a new piece of code. Python m PyTest. We're going to use another particular flag. It's called verbose. Verbose basically will give you the entire output in a different way. I'll show it to you. So test underscore primes.py. Now let me run this. So it's trying to see if all of the numbers that we have passed are using the fixtures. So we have not explicitly defined this, and this number is not going to change for every single function that we pass, or we don't have to write it manually as well. So if you're a developer, you'll be like, nice. If you're a tester, even you'll be feeling good because you don't have to write the test cases manually for so long as well, right? So all these numbers are prime numbers. Let's change it up. Let's set 102. 102 is not a prime number. Now that particular test case, we have to save it first, of course, and then as soon as I run it, it's going to fail for that particular case because it is not prime. Now you can see, right? So 102 at the end of it says it is failed. So whenever you work with, again, me coming back to the same explanation, is PyTest is very, very simple to work with, as you can see as well. Now pretty much we have seen most of it. We'll see two other conditions. So the first condition is something very nice, something which you might not have come across. Of course, you would have all used floating values, right? Floating values are pretty simple to work with, and instead of 3, 3.0, 3.01, all of that. So let me write a very, very simple piece of code. You might be wondering why we're actually doing this now. So x is 0.1 plus 0.2, y is equal to 0.3. Perfect. Now let us print to see if x is equal to y, right? So x equal to y. Of course, we need to check if they're actually equal. Now, guys, when I go on to run this piece of code, what do you think is the output? What do you think is going to come here? We're trying to see if x is equal to y. All we're trying to add is 0.1 plus 0.2. So x is supposed to be 0.3, y is supposed to be 0.3, right? Let me run this piece of code. It says false. It says false. All you're trying to do, a very, very simple piece of code in assertion, tells you you're doing something wrong. Well, what went wrong, guys? 0.1 plus 0.2 is supposed to be 0.3. Y is 0.3. It's supposed to match. It's supposed to work. But then it says, no, it is not equal to it. You know why it's not equal to it? Well, you're going to find out now. Let me print the criteria where it's actually y is not equal and x not equal to y. Just by doing this, we're basically going to print the entire output of 0.3. See, 0.3 is not just 0.3. This is the output which has been truncated for you to see. So it's 0.3 followed by a lot of zeros, and there is a 4 at the end. This is why 0.3 0.0000004 is of course not equal to 0.3. But then when you do it directly like this, it's a bit confusing. Now that I've printed this out, pretty much you can figure it out easily as well, because 0.3 for representational sakes it's 0.3, but actually it's 0.3 followed by a lot of zeros, and then it'll have some value at the end as well, right? Now let's fix this whenever we are testing it, right? So see, when you directly run a test right now, it's of course going to say false because it doesn't make sense to it. 0.3 followed by 0.34 is not equal to 0.3. Now let's bring up PyTest. Let's import a very nice part of PyTest. It's called as approx. You're going to need this. Approx, as the name suggests, is approximation. So you're going to be using this a lot if you're working with a lot of numbers, right? So 0.1 plus 0.2, instead of just asserting it directly, let's say, you know what, it's approximately 0.3. So forget about that last entity, that last 4, which is either annoying or not annoying, and now just approximate it and say it's equal. Now it's going to say yes, of course, whatever you have done is correct, it's equal, and you have done it correct. That's really nice to look at, right? So I am sure this would have been something which most of you wouldn't know. And then coming to the last concept of this particular tutorial is something which is really used in a production environment. So let's say you're running a piece of code and you will run into infinite loops, right? Infinite loops, where it is in a constant state where it's continuously doing something which is 99% useless. So whenever we're trying to fix infinite loops, all we're trying to use is a concept called as timeout. Whenever we're doing timeouts is used to make sure we cut this infinite loop short to see if something's working or not, right? So to do this one particular concept, we have to actually install a subcomponent, which I am sure would already be present at this point of time. It's called PyTest timeout. Now this is going to basically tell PyTest that we're trying to perform a timeout operation and just see if it's installed. Okay, it wasn't installed. Okay, so that actually got installed. Next up, we're gonna open create a file. Let's call it test underscore timeouts, because we're trying to find out if our file will timeout or not, or if it will go into an annoying infinite loop. So import PyTest, of course. Let's create a very simple assertion, PyTest dot mark dot timeout. So just check for five time units. If it's working, if it's still stuck in a loop after 5 time units, then make sure that it fails and call it an infinite loop. So define test underscore infinite underscore. We have to, of course, use the sleep function. Sleep function is used to basically put it to idle. This is where we are simulating an infinite loop. Right, so to do that, the first thing we need to do is you have to import the time function. After the time function has been imported, we need to create a loop where we're trying to get it to sleep. So while true, of course, and then what do we do when it's true? We have to basically call time.sleep and put it to sleep infinitely, right? You can go on to print a message as well. Print a message saying, you know what, I'm sleeping. All right. This is, you don't have to do this, but it'll just make it look nicer. So now coming to a function definition where we have to test if it works or not. So let's test if it's actually empty. Let's check if it's actually sleeping, if it's stuck in an infinite loop. Test empty. So here all I'm going to test put a boolean expression pass or fail, where this comes as a part of timeouts inside our particular PyTest. So whatever we installed PyTest timeout, right? So this is a part of that, and it'll basically just tell us if our particular criteria is a pass or failed. See, if we are passing it, it means that your program is working fine. It's not put into an infinite sleep. If it's failed, it means that yes, your program is stuck inside an infinite loop. Right, now to test that, again, the most used piece of code in this particular tutorial, right? So PyTest, let's like print a fancy output. We're going to print the output of the expression as well as the test case. So we're going to use verbose and test underscore timeouts dot py. Perfect. Let me run this. Now, as soon as I run this, what do you think is going to be the output? It has been put to infinite sleep now, and then it waited for 5 seconds to see. See, we're trying to do a basic operation, right? We're printing sleeping. We're printing this message. This message will not take 5 seconds to print, even on a very low powered compiler as well. So what basically our particular output did was it tried to see if it was sleeping or not, and tried to see if it was empty. See, if the output was empty, it means that the entity was sleeping, right? So we timed it out. We gave it 5 seconds to check if it was still sleeping or not. In fact, we can change that out. Let's wait 10 seconds now. You can change this based on how long it takes to actually run in a real life production environment. But then, yeah, see, now it's going to start executing it. See, now it's been put to sleep. Now it's executing the part of the sleep. So it's going to take 10 seconds now instead of 5. It's just going to wait 10 seconds. And after which it's going to still print the exact same message to you. It was like, no, I had to time it out manually. I timed it out. So the output of it is to basically, print it out a couple of times. So this is the standard out. So basically this was supposed to be printed, right? So this is what the verbose output will give to you as well. So now you can look at your screen and you can find out that yes, so these are all the things that can be done with respect to PyTest. It is really simple, and this is the reason that it's been widely used. A lot of interviews, whenever you go for testing or any general Python interviews, is gonna ask if you know this, and if you know all of this, then it really adds a lot of value to your application as well. And in fact, if you're working in a production environment, this just makes it all easier, right? And then of course, so to wrap the session up, let me just quickly roll to this particular slide where I've given you the syntax of the assert keyword. See, whenever you're asserting something, the first thing you need to put is the condition that you have to assert. And then the second thing is you can put the message, the error message. This error message is when your assertion function will actually print whenever you have the assertion exception which gets raised, right? So let me roll back to the code. We actually did it in the particular test case, and I'm sure you guys would have noticed that as well. Look at this. X equal to hello, hello was not equal to goodbye, and here is where I've given the condition. after the comma is where I've told it to print me this error message, and the assertion error basically printed us that error message, right? Perfect. Coming to the final thoughts of what I have about this particular concept, PyTest has been amazing. It's really powerful. It's simple to use with to reiterate on the same thing. And of course, software testing is all about proving that errors exist, that bugs exist, that you can fix something. Testing is not about saying bugs are not present. It's about hunting for these bugs and fixing it actively, guys. So to wrap this session up, make sure you jump on this particular Python trend. I'm sure you guys know this. Python is preferred for almost everything: artificial intelligence, web development, natural language processing, deep learning, machine learning, whatever it is. Even for testing, it really is beautiful. So this means that there are a lot of jobs created. It is one of the top careers, as well, as I mentioned at the start of the session. So to make full use of this, make sure you have PyTest in your Python arsenal as well.
Just a quick info, guys, we do provide end-to-end training on Python. So if you're interested, you can check out the course details given in the description below. So this brings us to the end of this session. If you have any queries, you can leave a comment down below. Thank you so much for watching, guys.